Hello. So here is the begin data type which is defined in general.h. It is defined as follows. That is, it is this size is equal to 64, and this unsigned long int is type def as item type. That is, when I was working on a small project, I use it as a int, unsigned int. So I generally use item type and size as a global variable, so that when I make this big project, I don't have to change my functions. So this is item type, that is unsigned long int, and it is a size which is constant. That is, we can't change the size. So this precaution is taken by this const. So here there are 8 blocks of lower and 8 blocks of upper of each size 64. So we can say that there are 16 blocks, that is 16 words of size 64. So 64 into 16 equal to 1024. So in this way, big 1024 in data type is represented, and these lower are the last. For example, this will be lower, then after lower 2, then lower 3. So the means the most significant block is here, that is lower upper 8, and least significant block is here lower 1. So here, so in driver.cpp, so firstly, in addition, we have initialized number b1. So in cost.cpp, so here initialize number. So this accepts a pointer to big int data type. So we have passed here address of b1. Then we have initialized that b, and we have initialized b using this function that initialize. So here is initialize b, which initializes each array to 0. So here is initialize array, which initializes each array to 0. So in this way, we have initialized the whole big int data type, and after that, there is after initializing it demands the number from the user, and there is a string of 1025 size, that is 1024 size for storing the main our bits, and 1 byte to store a null character, and it is entered by the user and accepted. Then we have write in big int function, which writes in big int, and it writes str in big int. So in write, so in this function, so here this function is there. So here in this function, so there is a length which is str of str len of str, which is now 1024. It will be, or it will no, not, it will not be 1024. It will be given by the user, and it will be calculated thereof. So I is defined as length minus 1, and while I is greater than 0 and j is less than size, this stri minus this character value of I, that is ASCII value, that is 48, is decremented, and b of lower of 1 and size minus j minus I is assigned to it, and it is done according to that our problems demand that we have to give in a reverse order. So in this way, following that, it is done, and it is done for all lower 1 to lower 8 and upper 1 to upper 8. So all all are initialized by this write in function. So this write in function puts our str into this big int. So after that, after write in function, there is out function which shows us that what data is now there available in is big int. So this is write out big int b. So here in write out big int b, so here write, so in write out big int b, so here in write out big int e, b it is accepts pointer to big int, and it's print each array, and array is printed just like we initialize array. This array is printed by this function print array, and each it is passed each array as b is pointed. So there this dereferencing operator will be coming, and each is printed as from lower, each is printed from upper to lower, so that our what was the order it is maintained here. And in this way, the initialize number is done. Same is for b2, and initialize b3 means here only b3 is given 00 values, and nothing else is done, and then add big ints function comes. So in add big int functions, so here in add big we define carry as 0 firstly, then pass to this function. This function is add function. So what does this add function do is that this add function has num1. So here to num1 is this array is uh, converted into decimal by using this two decimal function, which is a simple function, that is for I equal to size minus 1, I greater than equal to 0, I minus minus. This thing is done, that is result is incremented, and k is also incremented by k into 2. So on each value this binary number is converted into this decimal number, and after that in this add function this number 2 is also converted to decimal. Then number 3, the addition of number 1, number 2 and carry is taken out, and it's seen that if number 1 equal to 0, or means this, if this condition is there, it will not execute. So because overflow will not be there if there is this condition. So so if this condition is not there, then we will find that answer equal to overflow num1 num2 carry. And then in overflow function, which is also a simple function, that is if num1 num2 carry, their addition is greater than, is less than maximum of num1 or num2. So here this, if there was happens overflow, the system assumes that this overflow, for example, there is some limit to this int, and then we have passed a function that is limit plus 1. Then then what will happen is that the system will treat it as 0, not as limit plus 1, because it will treat as dash the actual number minus the limit plus 1 minus 1. So in this way we have means we have checked if there is overflow or not. If there is overflow, we have written 1, or else we have written 0. So in this way the overflow is also checked, and if overflow is there, this answer becomes 1, and answer is 1, so there is one carry. And the part that is the system is assigning to that now number 3 is, we have converted it to now binary and stored into its results. So system is helping us in doing that. And then we have also notified user that here this, it is entered in this if statement, and this is the carry now. Or if the answer equal to 0, we then convert it to binary, and it is a simple process like this only, but their carry is 0, or else it may not, it is impossible to happen. But if due to some error it happens, we have notified user that error has happened. And in this way this, so in this way this add function is done, and this add being ints is, this is done here, this add function. And then in this way the add is done, and if lastly the carry is not equal to 0, we have notified the user that overflow has happened and we have exited now. So that means if carry is equal to 1, the overflow will happen, or else if carry equal to 0, it will be all right. So after that exiting this, and we have done it for all upper and lowers, and exiting this we get this sub, we get this int, and we have write out that big int, that is b3, where we have stored our result. And next comes the subtraction, where we initialize this process is same. And now for sub big ints, we go into subcalls.h, here subcalls.cpp, and here sub big ints. So here it is initialized, c is initialized, then complement of 2 is taken and is stored into c. So these complements of 2 function is nothing but it does complement of 1 bc and then adds it to with 1. This unity we have defined to store one value, and then this complement of 1 is done, that is if there is 0 make it 1, and if there is 1 make it to 0. And in this way this complement is done, and after that we have added to 0. And then we have made that complement to c. And after doing that we have added int for sub, that is big and complement of c. So we have used another function, because here if there is carry it is a valid answer, but if there is not carry then it is a negative answer, and answer is actually the 2's complement. So here there is carry, this carry is forwarded like the same, and if it is not equal to 0, we see out the answer and write out the big int, that is b3, that result. And if the carry, if there happens that this is the carry is 0, so we know that then negative number must be there, because overflow can't happen in subtraction. And we do a complement of 2 of that, and then b3 is stored into b3, and we insert minus and we write out b3, so that it is also done. So after that, so in this way subtraction is done. And in multiplication, what is done here is that in subtraction and addition, in both the blocks, the carry ripples, the ripple carry adder is simulated here in both the sections, so that efficiency of the system is not lost, precision is not lost, because we have made each word equal to 64, so that we are not losing the precision, we are not losing the numbers, and we are doing the most efficient way and most precise way in addition and subtraction. In multiplication, what is done here is that in multiplication, the addition is done, addition of two, in multiplication this fun function is called. And in fun function, if uh, in fun function this, if there is 1, then z is multiplied by, then up to z the addition is done, and z is multiplied by z into 2, as it is the case in binary number. And after that, if there is 1, then again the addition is done. So in this way the sequential addition is done of these, this b3 is initialized to b1 in first go, and then it results is also again stored in b3. So this b3 now stores the value of the multiplication, as b1 is added b2 numbers of times in b3. So and b3 is initially 0, so b3 stores the multiplication, and it is done like this carry add big int for multiplication, and this function is there. And if carry is equal to 1, that is at any stage the overflow has happened, so we exit the loop and we say that overflow has happened, so that no further calculations could be done. So in this way multiplication is done. And now I have made a file also, but I will again do it, that exe file. So g++ calls.cpp, subcalls.cpp, and this mulcalls.cpp, driver.cpp, and making it into bt20 csc 112 cp assignment 2.exe, and running this command, we get this exe file. And then executing this exe file. So here the addition has come. So we can also do it using files, but for a more understanding way, so I have done it using the string, so that all the results I can put and take on the display itself, console itself. So we can see that uh, all the things are in a proper order here. And let's give another, so that one carry would occur, so that we should know that the carry occurs here, and it gives the correct result here. So here carry is occurred, and the data carry has occurred here, and the correct data is there, and the result is also put in here. So let me show this result. So this is the result, that there is this, there is this one, because this one plus another one, it will be adding and giving 1. So here is 1, here is 0, because these all are 0, and there is carry forwarded to this, so it will be also 0. So this 1 plus 1 will be become 0, this 1 plus 1 will become 1, and in this way this addition is working fine. So now the here is subtraction. So entering the number for subtraction, let's enter this, for example. So let, after entering this, it is showing the correct data that we have put in here. And after let's say we put anything here like this. So here is also the correct data is there. Let us take a negative case number, that is this is more than this. So see what is happening here, and after entering into this, we are getting this data, and see this carry equal to 1 has came here. So it comes here that the here in the previous there was some problem, but now when I again did it, that it is 111 and it is there. So it says that negative number can be represented, but it has taken the 2's complement and it is showing the result correctly. So after that, let's take for multiplication. So let's for small numbers it will be fast, but for a large number, as the addition will be more, so it will be very it will be very slow then. So 8 multiplied by 4, let's check. 8 multiplied by 4, so it will come to 32. As we can see here, one is added. So in this way, these addition and subtraction are done in very efficient way, and multiplication is also done by repeatedly adding the multiplicand, and the multiplicand times multiply means repeatedly adding the multiplicand second number times. So in this way the multiplication is also happening. So here subtraction, multiplication, and the multiplications are done for big int data type, which is 1024 bit number. Thank you.